So this video is part two of our work on conditional statements. Okay. So in the last video, we talked about the if else, the basic structure, the basic way relational operators work. Okay. So we're going to start this section in talking about what happens when we compare strings. Numbers are at least integers are relatively straightforward, right? You can know if we say if something that has a value of 5, we're asking is it less than something that has a value of 3, it's going to be true. Okay. So strings work a little bit differently. So we'll get to strings more later as we go, but strings are in essence, they're going to be a series of characters. Okay. And each character is kind of its own thing. So we can talk about the characters of a string separately in ways that we really can't with a number. I mean, we don't really care about, if we have the number 123, we don't really care about the one by itself. It only has meaning within the number. Okay. So we can talk about these letters separately. So when we're doing a comparison here, okay, so what it comes down to is this ASCII value. Okay, and the book talks about that, and there's a table and everything. So every character that we type, every letter, every number, every punctuation has an ASCII value. The ASCII value is a number that is how the computer internally represents that letter. Okay. And most of it makes sense in that the letter Z is bigger than letter A in ASCII values. So that would make some sense. Okay. And but what is sometimes not as clear is that uppercase letters came first. So an uppercase A is smaller than a lowercase a, which seems a little counterintuitive. Okay. So when we're doing our comparison operators, or less than, greater than, equal to, whatever, um, it's going to start by looking at that leftmost character, the first character that it hits. Okay. So if I'm going to see if Alice is bigger than Bill, okay, what I've done here, if you convert the character, the first character A and first character B, into ints, it'll print out their ASCII value. And I think a capital A is 65, which should make a capital B 66. They do work that way. So let me go up and compile it. Let me run it. And yeah, we get 65 and 66. Okay. So that's what's going to happen when we do a comparison here. So if I say if S1, which is the Alice, if it's greater than, let's do a less than because it is less than S2. Okay. And I always like to put the brackets, although the book doesn't always print out. It doesn't matter. DDD. It doesn't matter. Just want to show that. Okay. And if I run this now, that should print out the DDD, which means nothing at all. Okay. And it does. So that's correct. If I would have done it the other way around, if my if were is that greater than that? Okay. If I run that, you'll see that it doesn't print at all. So it's not greater than. Okay. And if this were something that had multiple letters, okay, so I've got, first off, if we look at Bill versus Billy, okay, Bill runs out of letters before Billy does. So therefore, if you add up the letters that Bill would come before Billy because it has less letters. That's just how that works. But if we had like this, Billy, like this, okay, that letter only comes in because it is in the same they're not the same. They are the same. Okay. So in this case, it would compare big B versus big B, they're the same. It would then move big little I versus little I, the same. Little L versus little L, the same. Little L versus little L, the same. When it gets to here, this I comes before that Y. So therefore, this would be smaller. Okay. And that's what strings do for us. Okay. So there's not much else to that. Okay. So the next thing I want to talk about is the idea of having a nested loop. So with a nested loop, you can have a loop inside of a loop. Okay. So in this case, we're going to check for the balance on some account. Um, so we're going to say if the balance is greater, I'm going to put this in here, if balance greater than 50,000, then interest rate is 0.07. Okay. If the balance is between 25,000 and 50,000, it is 0.05. And if it is less than that, it's 0.03. Okay. So one thing I'll talk about more in a minute, we have to make sure for the off by one error. So we're going to have this balance. We want it to be in one of these categories. Okay. So we have to worry about this 5,000. Does the 5,000 appear here or does the 5,000 appear there? Okay. And whichever way you want to go is fine, but you need to have it somewhere. Okay. So and the second one's a compound with an and we don't really need to do that. If we start off by asking, is it greater than 50,000? Okay. Then all we have to worry about here is it greater than 25,000? Okay. Now we can't switch the order here. If we ask first if it's greater than 25,000, then 55,000 would be in that category. So you always have to start with the most exclusive first. Okay. So I can say it like this, and then I can just do a less than, that's fine. And I don't have to worry about the equal there. Okay. So that's the basic idea of what we're going to be doing. But we're going to do this in a nested loop fashion. And you'll see what I'm talking about here. Okay. So I'm going to start out on the lower or the outer one here. I'm going to say if balance is greater than 50,000. Let's make my balance character here. Okay. And the interest rate is equal to 0.07. That's going to end that. Okay. So up here, I need to go ahead and say a double balance and interest rate. Okay. In fact, we can just go ahead and set values here. No reason to build user input to this. So I'm just going to start off my balance is equal to 55,000.0. Then interest rate will be set. So I can just do a double interest rate set to nothing. Okay. So now that's my first option. Okay. If I have two more options, I can go ahead and put an if else inside of this, okay, to nest it over. Okay. But I like to test the outermost loop first. So I'm going to say test outer loop. Okay. And I just want this to say cout in else to let me know that's where I'm at. Okay, to make sure that's okay. Which means I want to change this to something that is not greater than 50,000. So let's say 45,000. So I want to make sure that I'm making it into this second loop. Okay, so let's run it to see. I'm in the else. Okay. And let's make sure the outer part's working. So let's go ahead and switch it back to 55, and that shouldn't print. I could put another cout, but I'm not going to because I feel pretty confident that part works. Okay, doesn't print anything, which is good. Okay. So now that I have this working, I can put in here, indent it over, an entire other if structure. Okay, so note I only get to where the cursor is right now, only if this first if was not true. Okay, so right here, I'm going to say if balance is greater than 25,000. Okay, let's say the interest rate is equal to 0.05. Okay, have an else inside of here that just says interest rate is equal to 0.03. Okay, that's all I have to do. Okay. And then at the bottom here, we could just cout interest rate. Okay, and we know those sections are working. Let's do something that's uh, really low. Okay, run that. We get 0. Why do we get 0? It's very interesting. Oh, because of that. You know, C++ used to give default values to just crazy stuff. You can never tell. I think now it defaults it to 0. Never assume that it's 0, but I think it does nowadays. 3%. So we're good. Okay. So that's how the nested ones work. And you can nest as much as you want to nest. Okay. So in looking at this code, keep in mind, I could have just done all if statements, right? I could have said if balance here, if balance there, and so forth. If you do multiple ifs, okay, one thing that you're going to run into is that the compiler or the computer when it's executing would have to do that check of the relational operator every time. Okay. Where if you have nested, if this value is true at this line, that's the only check it has to do. It's going to skip all of that and go on to the end. So the else and the else ifs into the nesting allows you to skip some of that. Okay. So something else that we can do, we can create in our programs is this idea of a compound logical expression. Okay. And we do that in C++ with the following operators. Okay. We can have the two ampersands, that's two shift sevens, is equal to a logical and. Okay. So that is true only if both items are true. Okay. And the space is screwed up, so I'm just randomly typing into Emacs. We also have the two vertical bars, which is the logical or. This is not an exclusive or, so this is true. If you say A or B, it's true if A is true or B is true or both are true. Okay. There's also a logical not, which is exclamation point, but it doesn't work in quite the same way. Okay. So let's take a look at this. So I don't know if registering for the draft is still a thing, but it certainly was when I turned 18. So let's say if age is greater than or equal to 18. Okay. And this is the old way to do it. I'm doing nested loop. Then I'm going to say if gender is equal to male, because it used to be the only men. I don't know how it is now. Only men had to register for the draft. I don't know if anyone registers for draft anymore. See out must register for the draft, which does not exist, but in case it ever does. Okay, so I can do that way. Okay, and that would work just fine. Okay, but since I'm testing two things, that's all I'm testing. I can make this a compound statement. So I can say, so I don't do anything if it's just 18. So I can say if age is greater than or equal to 18 and then I can just, if you want, pull that up. And gender equals male, then I need to, by hitting if you hit the space bar, it'll respace things around. Okay. But notice there's a problem here. I've got one too many of these. This ends the whole thing. So I need to get rid of that. Then it's back to correct. Okay. So this saying, let me go ahead and put these variables in here. I'm going to say int age is equal to 20 and string gender is equal to male. Okay. If I run this, it should, in fact, yeah, must register for the draft. Okay. So that's going to work that way. Okay. And or would work. Let's say you've got another age question, but let's say you have a discount. Okay. So if age is less than, let's say 12, or age is greater than or equal to, let's say, 80. Then we can say discount. And our age is 20, so there should be no discount for this one. Okay. Pilot, run it, nothing. We go back and change it. Let's make them 90. Discount. And let's make them 9. Discount. Okay. So we can use those to make our code go a little quicker, all that stuff. Okay. Some caveats when doing the relational operators is that if you're looking at numbers that have decimal places, the floats and the doubles, things get a little tricky. It's not always the case that C++ will store things like you want it to store things. So when you store a 1.0 as a double, it may really be a 0.999999. So testing equality can be a little bit difficult with numbers that are floats. Okay. So let's take an example and see if we can get it to cause trouble. It doesn't always cause trouble. So let's say we have int x is equal to 2. No, these are doubles that we care about. So let's do a double x is equal to 2.0. Now let's do a 2. Well, that's okay. No, let's do 2.5. Okay, let's do a double y is equal to 5 divided by 2, which should also give me a 2.5, but it may give it differently. Okay. And then I can say here, and this variable, this is unpredictable, is what the book says, and it's correct. So if I say if x is equal to y, let's see if that gives us the correct answer. In this case, it may. One never knows. It did not. Okay, so it's already incorrect. It should have, right? They should have been the same, but they weren't the same. Okay. So what you have to do if you want to compare these numbers, okay, you have to look at the difference and look at the absolute value of the difference to see if it's within some range that you care about. Okay. So to use the absolute value, we have to include the C math. Go up here and do another include C math. Okay. I've included that. And now when I have two numbers here, okay, I'm going to take the absolute value. Okay, so I'm gonna have some other variable. Say, does that need to be a double? Yes. Double D for difference equal to absolute value of X minus Y. Okay, so let's give the difference whether positive or negative. And then here I can say if D is less than, well, no, I could do that right in there. I'm sorry. I can do this right here. I can say fabs X minus Y. So if that value is less than, say, 0 point something like that, then we're going to call it equal. So I don't need this line after all. And put it right there, and let's see if this works. So it doesn't work. So did I mess up my math? Maybe. So let's see. So let me see out X, see out Y. Okay. Let's give me 2. Oh, because I'm dumb. I hate when we become dumb. I had 2.0 there because that's going to come back as an integer. Let's try that. There we go. And that may have worked before because that just says 2.5, but sometimes that's not going to be the case. It will not always store them correctly. Okay. So now it's going to take this absolute value of the difference between them. And that way, if one is one value and 0.99999 is stored someplace else, then you're going to be covered. Okay. So it's worth doing this whenever you're trying to compare anything with um, decimal places. Okay. So one other thing that the book warns us about here is something that would seem to make sense. So we like things to seem to make sense, but sometimes they don't. So let's say here that we have some number, an int x is equal to what, equal num. Okay, I want to check to see if it's between 0 and 10. So num is equal to 5, which should be. Okay. Then I want to put a range like we would do in math here. And I want to say something like um, if 0 is less than or equal to num, which is less than or equal to 10, and print out true. Okay, so if I run this, compile it, true. It is true. Okay, which it is, right? So 5 is right in here between. What if I make this a 20 instead? That should print nothing, right? It still says true. Okay. So why does it say true? Okay. Well, it says true because in C++, when you give it multiple operators, it does it from left to right. So it starts by doing this first part here. Okay. It's going to say, is 0 less than or equal to 20? That's true. So it's going to give me a 1 as the value for that. Okay. It's then going to say, is 1 less than or equal to 10? That's true too. So it makes the whole thing true. Okay. So that's never going to work. So what you would do instead, and people do this a lot, so pay attention here. Okay, you have to say if 0 is less than or equal to num. That's not what you need to say. You say if num is greater than or equal to 0 and num is less than or equal to 10. Okay. We do this and run it. Okay, we get that it's not. We get it as being incorrect. Okay. If I put my 5 back, that really put a 5 back? It did. Okay. Now it says that it's true. Okay. So that's why that works out like it does. Okay. So there's some things to watch out for when we're doing these conditional statements, especially if they're more complex ones. The one you have to think about, we mentioned that before with the one with the first example with 50,000. And it's the one of making sure that you have the most exclusive test first. Okay. So I always like to think here of a coin sorter. If you're going to make a coin sorter, I don't know if you've ever seen these little things, little home ones, where basically the coin comes down a slot and then it's going to go through a series of holes and it's supposed to fall into the right hole, right? So if you have a quarter, nickel, dime, and penny, the order of the holes can only be one way, right? The first hole has to be the smallest, right? It has to be the dime, okay? Because if the biggest is the quarter, if the first hole were the quarter, everything would be a quarter, okay? It's the way if you're doing, we always seems like we always have students do like grade calculations, okay? So if the first thing you ask is if grade is greater than 70, the score is a C. And then you say if grade's greater than 80, the score is a B, and then if grade's greater than 90, the score is an A. Okay. With that, every score over 70, so including the 80s and 90s, would all be C's. That's what hit first. So you got to make sure that you pick the most exclusive thing first and then go from there. Okay. We talked before about the off by one error. Again, it's difficult if you have a test where you're saying if X is less than 100, do this. If X is greater than 100, do something else. Well, you're missing what if X is equal to 100. So you have to worry about that. Okay. So there's also an issue with confusing a single equal and a double equal, and this is going to get you for sure. Okay. So let's do an example here. So we've got this. Okay. I'm going to say, what is that doing? What am I doing? I don't, if num is equal to 5, okay, I'm going to see out true. Okay. We run it, compile it, run it. Yeah, true, right? That's what we expect. But now let's say, what if num is equal to 50, which it is not. That shouldn't print anything. Okay, I'm going to run it. Boom. Still true. Okay. Why is it true? Because this is not asking a question, right? This is a statement. It's assigning the value of num to 50. It's not really. It's all inside of this little if statement. It stays inside of there. But this will always be true. Okay. So that's not going to do what you want. Okay. So you have to make sure that that is happening properly. Okay. So one other thing the book gives us, which is interesting, that we should do when we're using files. Okay, so let's say we're now going to include fstream up here. Okay. And then I'm going to do an ifstream on n file. Okay. I'm then going to say n file.open test dot dat for data. Sometimes files are called that. Okay. That is a file that does not exist. Okay. So if I run this now, see if it's going to give us an error. It does not. It's happy, right? Okay, so if I go back and look, I can even, I should have already done an infile.close. Okay. But if I try to use it, say infile x, x, okay, I run this, it's going to blow up. Nope, that's not what it blew up for the wrong reason. Let's blow up for the right reason. Blew up really. Still blowing up for the wrong reason. Okay. It didn't blow up, but it shouldn't have gotten a value. It's weird that it didn't blow up. Let's try that again. Let's see what it's doing. I'm getting X. Let me see out X. Yeah, sometimes you would like C++ to give you more errors than it does. That's very strange. It took some random, that's not a real number. I don't think there's a DAT file. That would be very strange, wouldn't it? No, there's not. Yeah, there's no file there. So it's just, that's even a worse problem in some ways, in that it's reading random data from somewhere in the world that really should give us an error message, and it doesn't. Okay. So what we can do before we do this, okay, we can use our if. We can say if not in file. Okay, that not is just going to simply return if it can't find it, if it's not proper. I can then see out, cannot open input file. Okay. Okay, and then I can, what doesn't it like? Why did you not go over there? There's this. That tells me something's not right, but I don't know what. Get rid of all that stuff. Okay, so I've got that. Got that. That seems okay. That seems okay. See how it's going the right way. I'm closing that indel. Yeah, something's unhappy. I guess I'll find it eventually. I don't need this stuff. I don't know if that's my issue or not. Oh, I do need that. Yeah. Okay. I don't need that. So I'm opening my test.date that I can do in file.close. Not that it matters. There's no file to be closed. Yeah, I don't see what I'm doing. What I want to do here, maybe they'll tell me what I'm doing wrong. Clearly, I'm doing something wrong. I'm going to return -1 here. Okay, -1 means we're stopping the program, but something weird happened. So let me just run this and see if it'll tell me what's going on. It seems okay, which is worrisome in itself. Okay, so it works. It just wasn't spacing it properly. Yeah, so it's saying it can't open the input file. So now it's okay. That's really super weird. Yeah, sometimes going out and coming back in will fix. So again, we're opening this file. If it doesn't open, C++ is going to keep on going. It's not going to care. It's not going to give you an error message. Even if you pull data from it, it'll be like, fine, whatever, I'll make up data. Okay. But if I say, if not in file, and then print out a message and shut down the program with an error status that we could do something about later, then it's going to close it down and not continue to behave in a strange way. Okay. So the last thing we're going to do today in this video is talk about a switch statements. Okay, and a switch statement is another way, another kind of control structure, okay, that can replace a bunch of if else ifs. So a switch statement is useful when you have a single expression, you're going to be testing it against a bunch of values, okay? So it's good, for example, if you have a menu, okay, there's this case and that case and the other case, okay? I will say that cases are one of the few examples that we teach in an uncontrolled transfer to a memory location. And as such, it can be a little dangerous. So if you're worried about a program having any kind of error issues, the switches can be hard to deal with, okay? But they do come in handy, okay? So if we do a switch here, that's the keyword, with some expression, okay? So that expression could be post anything that you want it to be. Okay. So, okay, so this switch expression can be a Boolean, it can be whatever. So we can just say X. So up here we're going to have, let's say, int X is equal to 5. Okay. Which certainly works. Okay. Okay. Then I got my switch on X. Okay. Which is going to take some parentheses. Sometimes it's good to put the bottom one in so you don't forget it. Okay. We have a series of cases. So we're going to have case 1, okay? Not because it's the first case, because we're looking to see if X is equal to 1. That's what we're testing here, okay? So if it is, we can see out X is 1, okay? And one important thing you have to remember is to put a break in here. Because what happens? So let's say we've got a case 2 here, okay? If we don't put the break in here, then once one of these becomes true, it's going to just keep doing all of them all the way down. Okay, so you have to put the break there. Okay, so let's do a little bit different example. It may make more sense. So let's do a day of the week. Okay, so I can do this on the day here. Okay, and then if it's equal to 1, I can put Monday. Okay, put a break. Okay, let's see out for case 2, I put Tuesday. Case three, and see out Thursday, no, be a Wednesday, and so forth. You get the idea. I can put a new line character there as well. So let's go ahead and do this as a two, for example. Okay. And then break. And you finally, the last thing you can have is a default. Default could be see out, day out of range. Okay. And I should still have my, the other thing you can do is our structure starts getting more complicated. I can put in here a comment to end the switch. Okay. So in the example that I have, since I've selected day being equal to 2, it should come down to this one and print out Tuesday. When it hits the break, it's going to go all the way to the end of the switch. Okay, so let's see if this works. Uh, what doesn't it like? Missing terminating character in line 24. Let's see what I did wrong. I did end my quote. That will cause you, and I should have known that because it stayed purple to the end, but I was not paying attention. That's just an Emacs thing. So it gives me a Tuesday. There's no space there, but whatever. We're okay with it. Okay. But let's look at what happens if we don't do the break. Okay. So let's say it's a 1. And we forgot the break. So I'm just going to take them out. Well, let's just kill them all the way. Let's decide I'm just going to go this way with it. Let me go ahead and put in these end lines just so it won't be so ugly. Okay, now if I run it, assuming I haven't made another typo. Okay. Now if you look, okay, it does a Monday, Tuesday, Wednesday out of range. Okay. So basically when I said day equal 1, it goes down to here and say, is this true? And it is true. Okay. So I'm then going to see out the Monday, but it doesn't care about this anymore. It's not going, it's going to stay in here and ignores that, prints out the Tuesday, ignores that, prints out the Wednesday, that prints out the out of range. Okay. So you have to put the breaks inside of each of those in order to not have trouble. Okay. So that's more information about control structures. So we've talked about using the if with strings. We talked about the idea of nesting loops, or sorry, nesting if statements. You can have an if inside of an if and so forth. Okay. We talked about some things to worry about, like there's trouble when we're doing floating point numbers, when we're comparing those, could be a trouble. Okay. And then at the end, we talked about using the switch statement, which is good if you have a discrete number of answers that you're looking for. Okay. We'll see switches, I think, probably most likely once we get to menus, but we're not going to get to menus till we get to loops. Okay. So if you have questions about this, make sure that you let me know.